Alright, so today we are doing synthetic substitution, which I find to be a very satisfying process. So it is the exact same process as synthetic division, except our final answer is not going to be written as a polynomial because we are not dividing anymore. When we are using synthetic substitution, we are evaluating the polynomial for a given value. So it's the same thing as plugging in that number and finding out our answer in the end. So on example 1, it tells us that my polynomial is p of x. Then I am evaluating that polynomial when x equals 4. So typically what we would do is p of 4 equals 4 cubed minus 4 times 4 squared plus 3 times 4 minus 5. And we would find that answer by doing all of that math. Oops. But today, we're going to use synthetic substitution. So we're going to check the same way we did before to make sure that all of our powers are there. We start with a 3, then a 2, then a power of 1, and then a constant. So they're all there. And this time, instead of flipping to the opposite sign, we're going to keep it exactly as it is. So x equals 4 means we're going to use a 4. We're still going to put the coefficients at the top. So 1, negative 4, 3, and negative 5. Drop the first and multiply. 4 times 1 is 4. Add them. Negative 4 plus 4 is 0. 4 times 0 is 0. 3 plus 0 is 3. 4 times 3 is 12. Negative 5 plus 12 is 7. And now that's our answer. So before that was my remainder. Now it is what happens when I plug in that number. So that means if I would have done all this math, I would have got 7. They give me the same answer. So we would interpret our answer as 4 plugged into p. So p of 4 is equal to 7. So we'll do the same thing on the next couple of problems. So on practice 1, again, we're going to look for any missing powers. So we start with a power of 3, then a power of 2. We're missing a power of 1. So we're missing that x term. And then we have a constant. We're plugging in a negative 3. So our coefficients go on top. 1, 3, 0 for the x term, and 4. Drop the first, multiply. Negative 3 times 1 is negative 3. 3 minus 3 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. 4 plus 0 is 4. So my answer is 4. So p evaluated at negative 3 equals 4. Then on example 2, we're going to set it up. Looking for any missing terms, we have a power of 4 first, then a power of 3. We're missing x squared here. Then we have a power of 1, and then a constant. So the only missing one is x squared, and we're evaluating it at negative 2. Put our coefficients, 4, 2, 0 for the x squared term, 3, and 5. Drop that 4. Negative 2 times 4 is negative 8. 2 minus 8 is negative 6. Negative 2 times negative 6 is positive 12. 0 plus 12 is 12. Negative 2 times 12 negative 24. 3 minus 24 is negative 21. Negative 2 times negative 21 is positive. Sorry, the pen wasn't working for a second there. Is positive 42. And 5 plus 42 is 47. Last number is my answer. So the function p evaluated at negative 2 is 47. Then on practice 2, we start with a power of 2, then we go straight to a constant. So we're missing our x term. So when we set it up, we go 5, 0, 3. And if it helps you to write the labels at the top, then you can start by doing that. That would be my x squared first, then my x, then the constant. And we're evaluating when x equals 3. So we bring down that 5, multiply 3 times 5 gives me 15. 0 plus 15 is 15. 3 times 15 is 45. And 3 plus 45 is 48. So my answer is 48. So the function p, or the polynomial p, evaluated when x is, when x is 3, not 48, equals 48. So yesterday when we were doing division, we knew that we would have to take the opposite. So that means, this is just for fun, that means that we are dividing 5x squared plus 3 by the opposite, so x minus 3, and that equals 5x plus 15 with a remainder of 48. So just be aware of how to write your answers depending on what the question is asking you for. One key giveaway is that if it says x equals, then you know that your answer is your remainder. If it says divided by, then your answer will be a polynomial. So just a little heads up there. So then you've got 10 problems to work on for your homework, and they are substitution problems, so your answers should be numbers, not polynomials. So whatever your remainder is, that is your answer. So you do all 10 of those and then turn them in on Canvas, and then tomorrow we will get started with classifying our different polynomials.